Hello, and welcome to part 4 of our Foxic CAD-A-Long. In this part, we're going to cover how to handle IGS files, extruding to points, and CADing via a physical part. So in part 3, we worked on these wheel guards. We also added this standoff in the back to support the lifter. So let's keep working on the lifter of the robot. So the servo I'm going to use is the FingerTech HXT 12 kg Metal Gear servo, and I'll have a link to that in the description. So I'm just going to pop that up in Chrome. FingerTech Robotics is a great place to get insect weight robot parts. It's also great because they have the CAD files for pretty much every product that they sell, which is great for when you use their parts in your own design. So down here in the CAD file tab, and I'm going to download this IGS file for our servo here. So click on that guy, let it download, and then I'm just going to upload this into Fusion like we've done many times already. And with that imported, I'm going to go ahead and double click to open it up. So we've messed with step files before, and we've messed with STL files before. So this is our first IGS file that we've messed with. On the surface, it seems totally fine. You know, it's handling the rounded corners. Looks like a normal body that we'd use. But if you actually open this up and check out the bodies here, it's actually made out of all these unstitched new icons that we've never seen before. So the way an IGS file works is they're actually a collection of surfaces rather than a solid. So each one of these faces is a different object somewhere in this giant list. So this is not ideal for what we want to do, but we can easily get around this by clicking on one of these guys, then scrolling all the way to the bottom to select all of these. So I'm just going to hold down Shift and click on the last one here, and that's going to select every single one of these bodies. And then we can either go over to the Surface tab and then click on Stitch, or as usual, we can just push S on our keyboard and type whatever we are looking for. So with the Stitch tool selected, what it's going to do is take all of these seams and combine them together to make a solid object. So basically what you want to do is make sure none of these lines are red. Usually Fusion's pretty good about this. You might have to mess with this tolerance bar or use this set max gap as stitch tolerance button, but since everything is green, there's no red anywhere, we're good to go. So I'm going to hit OK on that, and now we have a body. And then lastly, I'd like to assign an appearance to this just to make it look a little bit more like the actual servo itself. So I'm just hitting A to bring up the appearance panel, and I'm just going to look for a black. Matte black is just fine. So you may have noticed something's missing here. There's actually no servo horn in the CAD file that's provided. The servo horn is that little arm that attaches to the servo here, and that's what we attach our linkage to and stuff like that. So that's pretty important for us, but unfortunately FingerTech doesn't include that in their CAD file, but it's good for us because now we can learn how to CAD that ourselves by buying one and measuring it. So let's open this up, and I'm going to add a new component and call it horn. So here on my desk I have one of those servos, as well as my trusty calipers. I'll leave a link for it in the description. So let's get to work on how we want to CAD this guy. So the first thing I want is the gap between the servo and the horn, and that's where I'm going to make my initial sketch. So I'm going to rotate this around, and then I'm going to use the gap between the servo here and then the horn. So let's turn this guy on, and I'm not going to use the bitey part of the calipers. I'm actually going to use this guy up here, and I'm going to position this like so, and then grab that distance. So we're getting about 5 millimeters. So in Fusion, I'm going to go to Construct, and we're going to use an offset plane. So what this does is it generates a plane offset from another plane. So I'm going to select the this flat part of the servo here, and then add the 5 millimeters that we measured. Hit OK. So you can see this will be like the bottom part of the horn relative to the servo here. So now we can make our sketch on top of this plane. And, you know, we can just kind of rough out how it'll look. You can see it's kind of like a rounded circle here, and then another rounded part here, and then just lines connecting them. So let's replicate that. We'll have a circle, another circle, and then some lines that connect them. So let's get an idea of what the diameter of these circles are. So we'll measure the whole thing here. And we're looking at about 12.86-ish. So I'm just gonna say 13. So now let's grab the other bit. Looking at about 7 millimeters there. Cool. And now let's get the length of the entire thing. I'll go with 39 millimeters. Because, you know, if I scooted back, I'm not really adding that much extra space there. So let's use 39 because that's a nice number. So I'm going to make a point. Here, actually, I'm going to make a line. From here to here. And that's going to be 39 millimeters. This line is going to be a horizontal line. It's also a construction line, and we want this point to be a coincident on that line. And you can see it's kind of coming together here, but it's not completely defined. Let's make it a coincident on here as well with this circle. So I'm gonna click on the line, control click on the point inside of the circle, and click coincident. So that's looking pretty good. Then the next thing we want to do is lock down these blue lines. If you take a look at the tangent tool up here, basically what this does is it has the line stick to the outside of the circle so that it doesn't penetrate the circle and meet at multiple points. And that's pretty much what we want to lock this guy down. So we're going to use the tangent tool here. I'm going to select the line and then this circle, and then you'll watch that line jump up here. So now it's only touching in one spot instead of in multiple spots. Then I'll do the same thing with this line in this circle, and then over here we will make this line a tangent of this circle and this line a tangent of this circle. Now you can see we have a defined outline. So let's measure the holes here in the servo horn. So these holes are tiny, and that makes it a little bit tricky to measure. So what I'm going to do is measure the rightmost tip of the circle to the edge of the horn here. So not the center point of the circle, because if I shove the calipers in there, it's not centered. And we're looking at about 0.256-ish. I'm willing to bet that it's actually 2.5, and I can't quite get the caliper tip all the way to the edge because of how tiny that hole is. So I'm willing to bet 2.5 for that distance. So let's go back to Fusion and add a hole, and I'm going to add it on this line that we made in the center, being careful not to also stick it to one of the lines of the servo in the background. And let's make a few holes. On the servo, there's 1, 2, 3, 4, 5, 6 in total. 6, there we go. And I guess we'll actually need one in here. And I'm going to use the equal tool to make these two equal. Then I'll use the equal tool again to make this one and this one equal, and then so on and so forth. There we go. And let's add a point. And I will make this point a coincident on this line. And then I'm going to say the distance between here and this circle, or I guess I'm going to need another point here as well. And this point will also need to be a coincident so that it resides on this line. And the distance between these 2 points is 2.5 millimeters. There's our first circle there. So that one's positioned, and with that one in place, we can kind of guess at where all the other ones should be. The tiny holes here really make things difficult, but I'm going to try to just eyeball how big one of these holes are. I'm gonna guess these are about 2 millimeters in diameter. So back in Fusion, you'll see that this circle here is already defined, and that's because we told Fusion that this circle and this circle share a center point. That information combined with the distance between these 2 points was able to tell Fusion what diameter this circle should be. So that one's already defined, and it actually should be the 2 millimeters we got. If we add a dimension here, we're getting an error saying that this dimension isn't needed because it's already defined. So this dimension is kind of like a I guess a read-only dimension is a way of describing it. All this dimension is saying how big the circle is. It's not the other way around where this dimension decides how big the circle is. So anyway, if we take this value and we plug that into a calculator from inches to millimeters, you can see that it's 1.999999 millimeters, so basically 2 millimeters. Now we just need to figure out how much space there is between each of these other circles. So back on the bench here, I'm going to measure the left tip of this hole and the right tip of this hole by putting my calipers like so. So there's probably some inaccuracies because of the tiny holes and the big prongs of the calipers. So I'm going to go with 12 3/4 of a millimeter. With how small these are, being off by fractions of a millimeter isn't going to be too big of a deal. So let's add a point here and a point here, or not there, here, and then this point needs to be a coincident so that it's in line. So the distance between those 2 points is going to be 12.75 millimeters. Now we can kind of get an idea of where these other circles are going to live. Now we don't have to measure any more of these. We can just use the line tool to add some lines from the center point to the circle next to it. So then we can also make one from here to here, then one from here to here, here to here. Make sure I'm getting the right point there. And then the last one from here to here. So now I'm going to use the equal constraint and say that this line is equal to this line. And then this line, not the, I'm gonna make sure I grab the little line here, not the construction line in the background. So this little line is the same as this little line, and this little line is the same as this little line. And then this little line is the same as this little line. And there we go. We have all of our circles, and our servo horn is ready to be extruded. So let's take a look over at this angle, select all of these except for the circles, and we'll extrude this to make the horn here. So let's go back to the actual servo itself, and let's measure how thick this thing is. Make sure I'm zeroed. And we're looking at about 2.5 millimeters. I'll make it 2.55. here we go. Now we have a little servo horn. And actually, let me undo that real quick. There's one thing we need to do here. So you may notice that there's no timeline at the bottom of this file. So let's right click this guy and do capture design history. That way when we add more features and stuff, we don't lose our work and we can keep things parametric. So now that we have a timeline, I'll select these again, do our extrude, and do our 2.55 millimeters. 55. Cool. So that's in position. Now let's do Shift J on our keyboard, and we'll select the horn and the servo, and let's make this a revolute. And then the position is going to be this center point. And now we have a horn that will rotate around that axis. So if we look at our servo here, look at it head on, you can see that it's thinner here, and then as you get towards the shaft of the servo, it kind of bulges out and gets a little fatter. So I'd like to add that extrusion on the top so that we don't have it bumping into anything in our model. I'm going to measure where that extra width starts out. So I'm going to hold it flat like that and just bring this along until it hits the end of the slope there. And we're looking at about 15.5 millimeters. So let's add a new sketch to our horn with the horn as the active component in Fusion. I'm going to add a line like that, and you can see since I kept it vertical, it added a horizontal vertical constraint for me. Now we just need to position this line from the edge like we measured. So let's add a point. And it looks like that center point will be just fine. So I'm going to use that point. It's a center of this arc, basically, is what that triangle is indicating. So from here to the line, we're going to do 15.5 millimeters. And now we have this little part that we can extrude out like that. But then the question is how much? So let's actually cancel this and add a new sketch. It can be anywhere really. I'll just put it on the face of this here, this servo. And let's add a line, or let's project this flat part like that. And let's add a line sticking up from this point. This will be a vertical line. If we look at it like this, now we just need to figure out how tall this is. So basically what I'm doing is I'm measuring the distance from the top of the servo here, like this rounded flat part, to the top of the extruded piece, the extra fat piece of the horn. So back in the bench here, 0 that, and I'm going to measure this a little bit different. Instead of using the bitey part, I'm actually going to put the bottom of it against the horn like this. Now you'll see when I move this back and forth, it's also moving this little thing out of the back. So I can put the calipers like so on top of the extrusion and then measure down like that until it hits the base to get a measurement. So it looks like about 9 millimeters. So back in Fusion, let's make this 9 millimeters. And we're going to do something a little bit different here. Let's finish that sketch. Now we want to make sure when we do this extrusion that this other sketch we made is also visible. So I'm going to hit E on the keyboard here, and I'm going to do an extrude. But instead of distance, I'll do to object. Now normally we pick a face or something that we stick it to, but this time I'm actually just going to click on this point, and it'll go up. It'll extrude up to that point. The height of that point. So we'll hit OK on there, and there's our little fattened extrusion part of the servo horn. So with that, our horn is complete, and our servo is now ready to be thrown into our Foxic design. So that will do it for part 4 of our Foxic CAD-A-Long. Be sure to leave a comment if you have any questions or general comments about the series, things you want to see improved, all that good stuff. Also make sure you subscribe so that you're notified when the next part of the series comes out, and I will see you all next time.